Hi everybody, welcome back and happy Monday. Today we're going to do lesson 2.8 and we're going to talk about how we find protons, neutrons, and electrons if we have an atom and if we have an ion. So we'll be distinguishing the difference between those two. So this is the page you should be on in your notes, and this little chart is basically going to teach us how to find protons, neutrons, electrons if we have an atom. So let's define what an atom is first. You probably know that atoms make up everything. That's why you can't trust them, right? And that they are the building blocks of all matter, from which all matter is made. But atoms are always neutral. They're neutral, which means their charged particles must be equal, right? Their pluses must equal their minuses. In all atoms, that is the case. So to find protons in an atom, again, it's the same way you find protons in anything. Protons is equivalent to the atomic number. Again, with the hashtag. Let me write out numbers so you don't think it's a hashtag. So if you are given a symbol, an isotopic symbol, something like Li37, remember the bottom number is your atomic number. And so lithium here, Li, would have 3 protons. And remember, protons are the positive charges, so that indicates it has 3 pluses. Remember, protons also equal the nuclear charge. So by knowing the protons, by knowing the atomic number, I know how many pluses there are, and I also know what the charge of lithium's nucleus is. It would be +3. It's equivalent to the protons. Okay? If they do not give you a symbol like this, if they do not give you an isotopic symbol, then you will have to go on the periodic table and look up the atomic number. So example, for sodium, I'd have to get the symbol first. So if you don't know the symbol for sodium, you could go to reference table S, look up sodium, and you will find the symbol. And then you would go to your periodic table and find out what its atomic number is. Okay? So we know that sodium is Na, and then we would go to our periodic table, our reference tables. There we go. Sorry about that. Nobody wants to work on a Monday, not even the computer. Maybe, there we go. Okay, so let me slide this over so you guys can see it a little bit better. But here's our table, and if you look up Na, it's right here. Okay, so here's sodium, its atomic number is 11, which would indicate that it has 11 protons. So in our notes here, we could just fill in its bottom number is 11, and therefore it has 11 protons. Okay? For neutrons, in order to find neutrons, since if you recall the mass number is equal to the sum of protons and neutrons, to find neutrons, you subtract the atomic mass minus the atomic number. Again, so for lithium, to find our neutrons, you'd have 7 minus 3, which would give you 4 neutrons. And remember, neutrons are neutral. Neutrons only contribute to the mass of the atom, not the charge. For sodium, again, they did not give us the mass, which means the only place you can get the mass is from the table. So you would go back to the table, you would look up sodium's mass here, and you notice it's a decimal. We'll round that to the nearest whole number. So this would become 23 as the top number for sodium. So we'll fill that in up here, 23. And then to get our neutrons, we would just subtract. Number of neutrons equals 23 minus 11, which gives us 12 neutrons. So our neutrons equal the atomic mass minus the atomic number. If the atomic mass is given, make sure you use the given atomic mass because it can be different than what's in the table. But if the atomic mass is not given, then you need to look it up on the table. And then finally, electrons. Well, if you're paying attention to what an atom is, the pluses and the minuses must be equal in an atom. And the minuses are electrons. So in an atom, the electrons are always the same as the protons. Okay? So for sodium then, since it had 11 protons, it would also have 11 electrons. Since lithium has 3 protons, it would also have 3 electrons. Okay? I would like you to try letter B. If you did not already try it from last week's lesson, I'd like you to try letter B on your own. You could do it right in your notes and I'll come around and check it on Tuesday, tomorrow. What happens though if you don't have an atom? What happens if you have an ion? Ions are simply charged particles. Okay? There's 2 ways you can be charged. You can either have a positive charge or you can have a negative charge. Remember, because if you don't have a charge, we call you an atom. But if you do have a charge, we call you an ion. So positive ions are known as cations, and they have positive ion right in their name. If you look, there's positive ion, right? Those are cations. And negative ions are known as anions. N for negative, ions, okay? So an ion is simply a particle where the positives do not equal the negatives. There's one of more or the other, and it depends on what you are. If you're a positive ion, you have more positives. If you're a negative ion, you have more negatives. But how do you become an ion? How do you go from having equal amounts of particles to no longer having equal amounts of particles? There's really 2 ways. Atoms can lose electrons or they can gain electrons. The protons never change, remember? So the way you would get more positives is by losing negatives, right? You lose electrons. So if you lose electrons, which remember are negative, then you become a positive ion. You become a cation. And if you gain more negatives, right, then you become a negative ion. You become an anion. So you don't change the protons, you just change the electrons. You either get more negatives or less negatives, and that's how you become an ion. So if you are an ion, then how do you find protons? You find protons the same way no matter what, right? Protons are the atomic number, so it's the same. How about neutrons? Again, neutrons are the same. So you take the atomic mass minus the atomic number for neutrons. But what's different is how you find the electrons. Because remember, the only thing that changes from an atom to an ion is electrons. You either have more or less. So it's somewhat opposite. If you have a positive ion, that means that you have lost, right, electrons. You've lost them. And so you'll have less electrons. So if they want to know the number of electrons and you have a positive ion, you just take the number of protons and subtract from it the charge. I'll show you an example in just a minute. If you're a negative ion, that means you've gained electrons. You now have more electrons. So you take the number of protons and you add to it the charge, because that would indicate that you have gained extra electrons. Okay? So let me show you a couple of examples of that, and then I'm going to have you do some practice. Okay, so this is not a warm-up, but we'll do these I'll do these with you, and then I'll give you a couple to do just for practice to bring in tomorrow. So it says determine the number of protons, neutrons, and electrons in the following ions. You can tell these are ions because this is their charge, right? If it were just a copper atom, there would be nothing here. There's no charge represented. So that would just indicate a copper atom, where the P's equal the E's. But since they gave us a charge, we will use it. That's how we know it's an ion, and obviously it's a cation. So we have Cu plus 2, and they want protons, neutrons, and electrons. Remember, to find protons, I have to look up the atomic number. They did not give it to me, so I'll go here to my periodic table, and we'll look up our atomic number. If you can see here, here's copper. The atomic number is 29. So we'll fill that in our symbol, 29, which would indicate that copper has 29 protons. Okay? Since the charge is positive, that means it has lost 2 electrons. That's what this means. It lost 2 electrons. If that charge were not there, it would have had 29 electrons because the protons and electrons are always equal. But it lost 2. So now it has 27 electrons. That's what I mean when I say it's the protons minus the charge. When you have a positive charge, you do 29 minus 2, and you get 27 electrons. And then for the neutrons, remember, we go and we look up the atomic mass because they didn't give it to us. Round it to a whole number, 63.5 rounds to 64. And to find neutrons, we take our 64 minus 29, and that will give us neutrons. 14 minus 9 is 5. 5 minus 2 is 35, right? So we have 35 neutrons. I better check my arithmetic. It is a Monday. Okay, 35 neutrons. So we'll do the same thing for this anion of nitrogen, which we would call the nitride ion. They did not give us the atomic mass and atomic number, so we should go look those up for nitrogen. And if you go here to the box for nitrogen, let me see if I can line that. There we go. There's nitrogen. You'll notice it has an atomic number of 7 and an atomic mass of 14. So I'll go fill that in my symbol. We'll just put it right here, 14 and 7, which means it has 7 protons. The -3 means it's gained 3 electrons. It would have had 7, now it has 3 extra. Remember, a negative charge means you get more electrons. A positive charge means you have less. It's kind of hard to remember. Negative means more, okay? So 7 protons, which normally would be 7 electrons, but the -3 means you have 3 extra electrons. So that is 10 electrons. And to find neutrons, remember you subtract these. 14 minus 7 gives us 7 neutrons. Okay? So I want you to do a few, and we'll kind of give you a couple. I just want you to tell me the protons, neutrons, and electrons in these 3 things. Number 1, magnesium, let's say 26. Protons, neutrons, and electrons. Number 2, how about a fluoride ion? Fluoride ions are what you need to prevent tooth decay. Fluoride is added to our water, and it's in toothpaste. So that's fluoride ions. And how about some manganese? How about some manganese plus 7 ions? Those are a fun one. Mn plus 7. So please, on a separate sheet of paper, protons, neutrons, and electrons in each one. Have a great day, everybody. We'll see you tomorrow.